Today we're looking at rhombus, rectangles, and squares. The goal is to be able to identify which one by its definition, description, and by the theorems that set them apart. So let's look at how they're described by definition. This is a parallelogram. Its definition or its description is that it is a quadrilateral with parallel opposite sides. Okay? So as I look down here, the qualities of a parallelogram, or the pieces of a parallelogram, I know its opposite sides are parallel because that's its definition. We also know that the opposite sides are congruent because that's what 6.3 told us. Theorem 6.3 said that if a quadrilateral was a parallelogram, then opposite sides are congruent. 6.4 said that if a quadrilateral was a parallelogram, then its opposite angles are congruent. This is 6.5. And 6.4 said that if a quadrilateral was a parallelogram, then its consecutive angles are supplementary. And then 6.6 says that if the quadrilateral is a parallelogram, then the diagonals bisect each other. So these are all from theorems. This is a definition. Now looking over here at the rectangle, by definition, a rectangle is a parallelogram that has right angles and opposite sides congruent. So these markings. Okay. Well, those are all the definition of a rectangle. So all of this, the opposite sides are parallel because it's a parallelogram. It meets all of these within its definition. So that's the definition of a rectangle, along with the angles all being equal because they're right angles. So this falls under the definition. And diagonals are congruent. That is Theorem 6.15. It says that if a quadrilateral's diagonals are congruent, the quadrilateral is a rectangle. So that's Theorem 6.15. Now, I want to go to a rhombus because it has less things checked on it. A rhombus is defined as a parallelogram with all of its sides. So we have to mark that they're parallel. And then all of its sides are congruent, which means they're all the same length. Okay? So parallelogram, these first things right here, these first features, are all the definition. Then there's a theorem 6.13 which says that if a parallelogram has diagonals that bisect or that are perpendicular, then it is a rhombus. So this is 6.13. And then another theorem 6.14 says that if a parallelogram has diagonals that bisect opposite angles, it is a rhombus. So that's 6.14. Okay. Now, looking at the square, it is a mix between a rectangle and a rhombus. So here's how it works. It is a quadrilateral that is a parallelogram. So all of these pieces that are a parallelogram are part of its definition. So all of this is its definition. But then it is also has all congruent sides. So this is part of its definition. And all of its angles are congruent because they're all right angles. So all of this to there is the definition of a square. So a square can actually be a rectangle, right? Because it meets all of these qualifications. So it is, its diagonals are congruent because it is a rhombus. It meets all of these conditions. So this is a 6.13, and this is a 6.14, and it is a rectangle, so it also meets the diagonals being congruent. So that's 16. So this chart is a way to help you keep track of which characteristics the quadrilateral has and why. So definition versus theorems. Okay? So that should be helpful to keep things a little bit more straight in your head. So now let's look at some of these right here and just figure out what they are. So take a second, turn off the video, see if you can match these images with the information you have up here. Okay. I'm hoping that you tried it before you just continued forward. This has all the sides. It tells you it's a parallelogram, so we know it meets all these criteria. So it's all of these. So then I'm looking at the separating features. This part right here that identifies which of the more specific quadrilaterals they are. So because all of the sides are congruent, then I go here to all sides being congruent. I'm looking at a square or a rhombus. To be a square, though, it has to have all the angles the same size, specifically right angles. Those are not noted. So this is actually a rhombus. And it has 4 sides congruent and no right angles. So that's why it's not a square. This one right here has, again, a parallelogram, so it meets all these first features, right? So then we have to look for the other features that qualify it. So it has opposite sides being congruent. So that's part of the definition of the parallelogram. Then it has right angles being congruent. So the right angles are congruent, which means that all the angles are congruent here. They're all right angles, so they're all congruent. So that makes this a rectangle, because it's not a square because these aren't marked as the same size. So this is a rectangle because it has right angles that are congruent, right? So that's why that's a rectangle. It's not a square because the sides aren't the same length. This is, let's see, it has a right angle here. If these 2 lines are parallel, this is a transversal. It says if a line is perpendicular to another line, if 2 parallel lines are perpendicular to one line there, if a line is perpendicular to a line that is parallel to another line, then these 2 lines are perpendicular to the same line. So this is perpendicular. So this basically tells me that all of these are right angles. So this has got all my right angles, which are congruent, and then it doesn't tell me that the sides are the same length, so this is, again, is a rectangle. Right here, I have all right angles, and they're all congruent, right? So all my angles are congruent. And then I have 4 congruent sides. So congruent sides and congruent angles makes this a square. So this is a square. Alright. Now I want you to try this part right here. It says find the measures of the numbered angles in each rhombus. Okay, so to do that, you have to know how the relationship works. Remember, for it to have a rhombus, the diagonals are perpendicular, and they are also, they bisect the opposite angles. So that means that in this picture, angle 1 and angle 2 are congruent because they bisect, right? So those are congruent, but then they're all congruent to each other because it's a parallelogram and opposite angles are congruent. So those 4 pieces are all congruent to each other. Then I know that the interior angles of a quadrilateral are 360 degrees. Sides 4 minus 2. So 4 minus 2 is 2 times 180 is 360. So this is 360. That's my interior angle theorem, interior sum angle theorem. And so here we go. I've got 360. I'm going to subtract 73 twice, which is 116. And then I'm going to divide it by 4 because whatever's left over is going to be divided amongst those 4 pieces. That's going to give me 53.3. So all of these angles are 53.3. Okay. Over here, I have another situation. I have that they're perpendicular, or the diagonals, right, because they go through opposite angles, the diagonals bisect each other in a rhombus. That's one of the descriptions up here. The diagonals bisect. The diagonals are perpendicular. Here we go. diagonals are perpendicular, so that makes this a right angle. Okay? So then if that's a right angle, angle 2 is a right angle, which makes it 90 degrees. Angle 3 is congruent to this angle right here, so angle 3 is 70 degrees because these are congruent, right? It bisects the angles. The diagonal bisects the angles, so it's bisecting these. So this again, this is congruent to that, which is congruent to that, which is congruent to that, which is what we saw in this problem right here. So those are all congruent. That makes that 70 degrees. And then the interior angles of a triangle are 180 degrees. So this right here was 70 degrees. This right here was 90 degrees. So 180 minus 70 minus 90, that makes angle 1 20 degrees. And because angle 1 and angle 4 are created by a diagonal which bisects the angle in a rhombus, then I know angle 4 is also 20 degrees. Take a second and figure this one out. Okay, you should have gotten that angle 1 is equal to 38 degrees, angle 2 is equal to 90 degrees, angle 3 is equal to 38 degrees, and angle 4 is equal to 52 degrees. Have any questions about any of that? Make sure you talk to me. Okay, here we go. So now we're looking at a quadrilateral that's a rectangle. So QRS is a rectangle. According to the information of a rectangle, when I'm talking about the diagonals of a rectangle are congruent. Right here. So I know that these two things are congruent. So if QS, which is a diagonal because it goes from opposite corner to opposite corner, and RT is a diagonal as well, that means these two things are set equal to each other. So x equals 6x minus 10, and that's going to give me that x is 129. No, I'm sorry. That's going to give me that x is 2. And because x is one of the side lengths, or the diagonal lengths, then the diagonal is also 2. Okay, so just setting each one of these up, I'm going to let you solve them on your own. These are both diagonals of a rectangle. The diagonals of a rectangle are congruent, which means that I can set the lengths equal to each other. Solve that. If you did the math right, you should have gotten the x was 9 and the diagonal was 29. So you should have completed that. And then here I want you to go ahead and do the problem. Come back to me. Did you get that x is 14 and the diagonal was 82? If you didn't, you might want to ask me some questions. Okay, next step. Determine the most precise name for each quadrilateral. So again, we're going back to all of our definitions. So this is a parallelogram, clearly shows me, right? And all the sides are the same length. Because that is how it's stated, this is a rhombus. In order for it to be a square, I need to note that this has got 90-degree angles. Okay? Here we go. This does have 90-degree angles. It is a parallelogram with 90-degree angles and all the sides the same length, so this is a square. This is a quadrilateral that has diagonals that meet perpendicularly and bisect each other. So let's looking at the diagonals. They're perpendicular and they bisect. So this is a rhombus. This one right here, I've got diagonals that bisect, or that are perpendicular. So when I look back over here to my information, my diagonals that are perpendicular, it's either a rhombus or a square, or something that's neither a rhombus or a square. But there's nothing that indicates the sides are the same length, so this is not enough information. Okay, you sort these. Okay, did you get that this was a rectangle, this was a rhombus, and this is a parallelogram? If you didn't, then you need to come see me so we can make sure you understand how to make sure you're getting the right, or identifying the right quadrilateral. Okay, and here we go. Our last thought. For each of the values of x in the figure, it has to meet the requirements so that it makes this special parallelogram. So these are diagonals. Diagonals in a rectangle, they bisect each other. So I know, and they're also congruent. So that means that these two pieces are congruent to each other. So setting my equation up, 5x minus 15 equals 3x plus 9. When I solve that all out, I get that x equals 12. So again, the reason I could do that is because the diagonals of a rectangle are congruent and they bisect each other. So again, this is a rectangle, so that means that I can set these two pieces to congruent to each other. I'm going to get 9x minus 9 equals 7x plus 1. When I solve that for x, I get that x equals 5. Okay, I want you to set this equation up and solve it. Pause. Did you get that x is 24? If not, you either set your equation up wrong or you did some math computation wrong. So see me, let me check it out. Okay, this is a rhombus. What do we know about a rhombus? Well, a rhombus has a diagonal that bisects the opposite angles. So that means these angles are congruent. And that makes these angles congruent. So these are the same size, right? So with that being said, I know that this is the same size. So I have 2x minus 1, and 4x plus 28. And together, they have to add up to the interior sum of the angles, which is 180 degrees. So that's going to give me that 4x minus 2 plus 4x plus 28 equals 180. And then I'm going to combine like terms. I'm going to get 8x plus 26 equals 180. I'm going to subtract 26 from both sides. X equals 154. 8x equals 154. So dividing by 8, I get that x equals 19.25. Okay, now you set this one up. You should have realized that this is a 90-degree angle, and it's half of a 90-degree angle, so this is 7x plus 3 equals 90 divided by 2 should have been what your equation was. You should have found out that x equals 6. If that is not the case, please let me know so we can answer your questions.